Earlier in our discussion on identifying relationships, I mentioned that you could potentially identify a many-to-many relationship during your data modeling, and that when you do, you should resolve them by adding a join table, which we'll discuss in our next movie. However, I'm frequently asked why many-to-many relationships need to be resolved at all. After all, FileMaker lets you create them, and they appear to work at least up to a point. So I'm going to show you some examples of where a many-to-many related structure would break down inside of a real FileMaker database. In the file that I've got here, if you open it up, you'll see that we have two tables, an actor table and a movie table. And in the actor table, one record represents any individual actor, and we've got unique IDs set up as a primary key field. In the movie database, one record represents one movie. Same thing here, primary key field to uniquely identify each movie. So what type of relationship might we have between these two tables? So consider the statement, one actor may act in many movies. So between the two tables, one actor could appear in many movies, which on the surface appears that it's a one-to-many relationship. If this were in fact a one-to-many relationship, we could simply add a foreign key field, or actor ID, to the movie table and create a direct relationship between the two of them. For example, if we look at this movie record here, I've got an actor ID field already on the layout, and let's say we determine that actor with the ID of number 1, Boo Radley, appears in the movie Yet Another Sequel. Simple enough, I can just put their ID in there, and now these two records are related. However, it's also true that one movie almost invariably involves many actors. So one movie could have many related actor records. So what you really have here are two one-to-many relationships crossing over between two tables, and not a true one-to-many in either case. And it's not so obvious how to solve that problem using the structure that I proposed a moment ago. Say, for example, this actor with the primary key of number 2 also appeared in Yet Another Sequel. You'd think that you could simply put another number in this field, or a comma in another number, but in this scenario, the actor ID field in the movie entity, otherwise known as the foreign key in this proposed relationship, would have to have more than one value at once. The technical term for this is a multi-valued attribute, and most database designers will argue strongly against the use of multi-valued attributes, especially inside of a key field in a relationship. So these multi-valued attributes are a bad choice for creating many-to-many relationships. Why is that? Well, for example, it could be very difficult to create a FileMaker Pro sub-summary report listing actors and their individual roles, or even a count of all the roles that they'd ever played, if all you're doing is simply just adding comma-delimited numbers to a field inside of an actor record. For example, what table would you use for a report like that? Our report would need to indicate one record per role that an actor has played in a movie, and we don't even have a table to support that. How could I create counts of actors inside of a movie, for example? Manually count all the different IDs inside of a field, or even do something programmatically? This wouldn't necessarily be accurate as the number of actors in a movie continue to grow. We would need something more dynamic. And another issue, what about the fact that you might want to store a character name that the actor played in each role, and maybe even the salary they received for doing so? These would actually be attributes, but attributes of what? Is a character name an attribute of a movie? No. Is a character that an actor played in a movie an attribute of an actor? Maybe if they've only appeared in one film, but what if they've appeared in multiple films? Many developers who aren't comfortable with how to properly resolve this issue may then try to create multiple instances of the actor ID in the movie record. Here's an example of that. This seems to easily accommodate the actor with primary ID number 1, actor number 2, and we still have some room. Then sure, in this case, you could store various actor IDs separately. However, this is still wrong. Now, if you wanted to search for all the movies that Jackson Camus appeared in as an actor, you would have to do 4 different searches, one in each one of these fields, just to make sure that you're not missing one of the IDs, because you don't know whether or not you've put his ID of number 2 in actor 1, actor 2, actor 3, actor 4. You're not even sure which field to search upon. That alone should tell you that something's wrong. Also, what if one actor appeared in 50 films? Or a movie had 100 different actors in it? Are you going to create 50 or 100 different films in your table just for that one actor, and their own special layouts inside of your database? Plus, then you'd have to create 50 character name fields as well as 50 salary fields. You should start to get the idea here that something's definitely wrong if you've gone down this path. In many database systems, FileMaker Pro included, you're much better off using a different strategy to resolve these types of relationships. And this strategy I'm proposing is actually a very easy one. You simply create a third table that we call a join table. And we'll discuss this approach in the next movie. By attempting to join two tables directly, we present issues where we can't find data properly, we can't report on it properly, or even view it efficiently. The modeling phase is a great place to find out that you have these issues, because you're just doing it on a piece of paper with pencil marks at this point, rather than having to go through several hours of development inside your database before you discover that you have a many-to-many relationship and all of its corresponding issues. Eventually you will. Instead, you'd want to create a join table to fix all these issues quickly and permanently within your solution.